I think I think we are live. Mhm. Hello and welcome all to the series. Welcome all to Fireblaze AI School, wherein the topic for today's YouTube live is data analysis for beginners. Now, if you are a beginner in this domain, if you are a beginner in this domain, you might be knowing a few, uh, stuff about the data analysis and how data analysis works. But this is not just for the beginners. This is the beginning part of data analysis, though. But anyone who is not a beginner and who knows something about data analysis can also see this YouTube live. It's possible you might be learning something new about data analysis in this video. All right, so let's get started with this video. Now, data analysis for beginners. So, but before starting with the steps of data analysis, let's discuss or let's understand if anyone knows or anyone understands what data analysis is. Okay, so let me select the color and then let's start with the presentation. So, what is data analysis? Yeah. Data analysis is what you can say is a science or a combination of mathematics and science wherein we, with the help of data, analyze a problem. So the main or major goal of a data analysis process is to solve a problem, right? This is very important to note because most of the times I've seen students, they usually focus on creating a tool, right? So for example, one might create a pivot table, right? But creating a pivot table is not data analysis. It is just one tool that helps us in data analysis. Again, performing ETL is a tool, is a process, is a one of the process in a series of process in performing a data analysis procedure. All right. So data analysis does not mean creating a dashboard or cleaning the data or creating pivot tables. It is a series of processes. Okay. So I hope you guys have understood what data analysis is. Let me write it down if it's possible. It is a process. Uh, Pardon me for my handwriting. I'm not very good at this. It is a process that okay, just the process with the I'm not sure what this is, but it is a process. Let's give me a second. I'm new to using this uh, technology. All right, it is a process that uh, uh, I accept my defeat. I won't be able to use this tab and pen. I'm not very good with this, so let me just tell you orally. Basically, it's a process that helps us, you know, uh, create something meaningful or some meaningful insight from a raw data. Right? We have a raw data. We take that data, we extract that data, and then we do a series of processes, and thus we are, what you can say, performing a data analysis process. All right. So again, whenever we are on to performing something or doing a project or doing something, we should follow a set process, right? We should follow a few set steps because If we do not follow this, it's possible that we might deviate from our goal. You know, uh, and it happens whenever we usually, I've seen wherever students learn data analyst, they tend to, deviate from their actual goal and end up performing something else, which might not even create meaning for the project. Okay. So what are these steps? Let's see one by one. So, to get an overview about these steps, these are the 8 steps that a data analyst should follow while performing a data analysis project. So, the first is understanding the problem. Understanding the problem is important because unless and until you do not understand what domain you are working on, or you do not have the domain knowledge about the project that you are working on, you will never understand the data. All right. And if you do not understand data, how will you ever make insights out of it? Right. That's right. You cannot at the end of this process, you have to explain your insights to your stakeholders. So unless and until you do not understand the data yourself, how will you explain it to someone else? Right. So the first step is to understand what the problem is. And once you have understood the problem, you should state it, right? You should state it down in your report, or maybe in your or on your uh, uh, maybe what you can say, maybe your summary or something. You should write it down, right? You should state the problem because stating is important. We'll see later on in this video why we should write a problem statement. So once we have written a problem statement, we try and we go out on the hunt to gather the data. We gather the data that will be helpful for us in analyzing the data, or what you can say, solving the problem that we have stated. This data will help us solve that problem. All right. So once we have collected the data, the next step is to clean that data. So not all the times it happens whenever we work in an industry or we work somewhere. Not always do we get a clean data. It very rarely happens because most of the times you do not get your data at a single source, right? For that you have to roam around on internet, maybe in the databases, maybe in the database of the company, maybe on internet, maybe somewhere else, right? Maybe on cloud, but that's internet, right? So you have to roam here and there to get all the data that's been needed. And in that process, it's possible that the data that have been collected from various sources might not be in the same format. It's possible. It's possible because somewhere, maybe in some countries like USA, people usually put a comma after every 3 numbers, whereas in India, in countries like India, we put a comma after the first 3 digits, and then after every 2 digits, we put a comma for thousands, lakhs, crores, and so on. But in some countries, they have thousands, millions, billions, trillions, and so on. Right? So, because of this discrepancy and many such discrepancies, the data that we have collected from various sources is not available in a same or a single format or a clean format. So, that's why we need to clean our data. All right. Once we have cleaned our data is clean. The first step that we start with when we are doing a data analysis procedure is to explore the data, which in other words is also called as exploratory data analysis. So we have to explore the data, we have to get an idea about how many rows, how many columns are present in the data. Then we have to get to know what type of data the table has. For example, if there are 10 columns, what data type does each column hold? For example, if there's the data for age variable, that data might be in integer, right? Or you may say it's a numerical continuous variable. Or if someone has their name, right? So name is again a text kind of variable. So we generally say it as a categorical variable, or to be more precise, we can call it as nominal qualitative data, right? So these are the types of data you'll know more when you'll learn data analysis. So once we have explored the data, we have got to know what data holds and what the column means. Then we move on to performing our actual data analysis, or we call it this was core data analysis. This is where we solve the problems, and this is what we you know learn in the classes, creating dashboards, making pivot tables, doing lookups, or what you can say, doing joins, using subqueries. That comes under the core data analysis, right? So we'll again talk about it more in the upcoming slides. Then comes the three steps that usually everyone tends to ignore. According to me, these are equally important to data analysis. So if the first five steps are important, so are the last three steps, which everyone tends to ignore. I don't know what the reason is why everyone ignores these three things, but there is no point in creating this dashboards and creating these pivot tables and doing this analysis unless and until you are able to explain them to your stakeholders, to your audience. All right. So the first step in the last three steps is interpretation. This means we interpret something from the data. We are reading between the data, right? So there's graphs, there's various other things, there's various other visualizations, there's KPIs, right? So what we are doing is we are reading between them. We are reading between them, and using them, we are trying to draw some insights from the data. All right. So that is what is called as interpretation. Right. Now, once we have interpreted our data, the next step is to communicate these insights to your audience. All right. Now, your audience can be anything. Your audience can be your friends, can be your family. I don't think so. Friends and families are that much, interested in knowing your data analysis because they are focused on something else. But still, it's possible that they are your audience. Then if you are a teacher, your students are your audience. If you are a data analyst working in a company, then your boss, your colleagues, your peers, your supervisors, they are your audience. If not, your client, your stakeholders, or your, what you can say, anything, your clients, again, they can be your audience. So unless and until you are able to communicate your ideas, your thoughts, your insights to them, there's no point in drawing those insights, because you are not the one who's gonna benefit from those insights. They are the one who's gonna benefit from it. So if they benefit from it, you will get the benefits, right? You are hired because you are increasing their business. You are improving their processes, or whatever data analysis they perform. So communication is the one of the most important skills when it comes to data analysis. All right. And then once you have communicated your ideas, the last thing is to prescribe them, the solutions to them. Again, because we started with a problem. If you can see, the first step for our data analysis was understanding the problem. So we started with stating the problem, and then we have to end with providing a solution. And that step is called as decision making, right? That is what is the action phase. That is where you take the action. That is where you rectify your what I can say. That is where you rectify your wrongdoings. All right. So this is the overview of the steps of data analysis. I guess uh, I have not just given an overview, but I have also given you an in-depth insight about the steps. But now let's try to tackle them one by one. So understanding the problem. Now, the first bullet point, it says define the objectives or questions clearly. Okay. So why is this important? Why is it important to define the objective or questions clearly? Because it will help you stay focused in the direction of that objective, right? For example, if I have sales data, I need to focus on the sales, right? I need to focus on maybe all the KPIs related to sales, such as profit, such as customer acquisition cost, or maybe marketing cost, or stuff like that, right? What happens if I do not focus on sales, but instead of I keep on generating random graphs that tells me nothing? For example, if I tell in the sales, I tell the gender distribution or the age distribution of my what I can say, the customer's age distribution is important. But what if I tell you the age distribution of my sales persons or my what I can say, sales agents? That is of no use, right? So this happens because we tend to forget what our objective was, and that's why it's important to state the objectives clearly. All right. So that's the first step. Second bullet point says identify key stakeholders. So key stakeholders means we have to identify who will be working on what. So whenever we are working as a data analyst, we need to specify who will be working on what part of it. Right? There will be one team that will be working on the ETL side of it, cleaning the data and gathering and storing it in a warehouse or something. The second team that would be working on creating the visualizations and writing SQL queries and all that stuff. And then one team would be working on gathering the insights and communicating them to the client. So we have to identify the key stakeholders who will be working on what. Right. Now, such examples of these are why are sales dropping. So since I have asked a question, why are sales dropping? I know my objective is to see or to check why sales are dropping and to solve this problem, to solve the problem of dropping sales so that my sales might improve. The second is which student group needs more support. So again, if I identify this is my objective to find out which student group needs more support, I will try to find out the answer to it and end up in providing that student group in actual more support than they require, right? Or not than they require, as they require, right? More support than they are getting now. So this is the first step, a very key step to performing a data analysis. Uh, you can say a project, right? To understand the problem, which means stating the problem, or we can also say problem statement step, right? The next step is to collect the data. Now, as you can see, there are various sources of data, which can be broadly classified into two. First is primary, and second is secondary. So, primary data sets are or data sources are those sources wherein you yourself go out and collect the data. The example for which is survey. So, for example, if you want to know in a specific area which or whom did those people in that area voted in an election. You need to go there, you need to ask yourself, you need to conduct surveys, you need to ask them who they voted for and just collect the data. Now, secondary data source is the source which is obtained from some other source. For example, some other primary source. So, for example, some other entity has done the survey or has done some kind of data collection, and you go and ask them for the data. Example for that is an internal system. So internal system is similar to for a company who has done their surveys, who has collected the data, and then you go to them and ask for their data. So these are the two sources of data. So usually it's said that you should never trust the secondary source of data, right? Secondary source of data usually has bias in it, is what they say. So if you want to make, proper decision or data driven decisions, you should always rely on the primary source of data. All right. So there's also other sources of what you can say data that you can find. First is sensors. So nowadays every electronic machine has sensors in it, and each sensor they generate some kind of data which is being stored in that database, and then you can use that data to optimize the usage of that machine. Nowadays this is happening. For example, if you are using mobile every Sunday, I think everyone gets a notification about how many hours you have used this mobile this week. I guess everyone has this kind of, uh, messages these days. This is happening, the data that the sensor has created. The sensor, they just check for how much time was the screen on for, and then that data is again aggregated to find out how much hours did you use this your phone for this week. All right, then there's public data that you can find various websites such as data.gov.in for all the Indian data sets. Then there's Kaggle, which provides a lot of open source data sets. But again, these data sets they are open source, and I don't know which if they are even secondary sources or more than that, maybe tertiary, quaternary. I don't know which hand source they are. So usually these are not very reliable, and most of them are fabricated data sets. So it is good for learning, but it's not good for actually making out some insights or real world insights out of it. So again, it's good for learning, but not for creating actual projects. Then this CRM. CRM is customer relationship management softwares. So this CRM softwares, everyone that's been working on the CRM software generates some kind of data. For example, there's leads that come into the picture that the salesperson they enter the data into the CRM, and thus you can you can extract the data from CRM. Then this questionnaires, which is basically nothing but surveys. Again, while collecting data, a very important key aspect is the ethical aspect, which means that there are three parameters: privacy, consent, and anonymity. So, whenever you are collecting data, these three things comes into the picture, and that's why it's very tough to find a real world data set, because all the real world data set might have some or the other kind of privacy involved in it, right? For example, a medical health data set, if I go to a hospital and I try to collect this data, it is against the law to ask for someone's private data. A medical data is considered as a private data, and I cannot access that kind of data. And that's why the privacy, the consent, and the anonymity. Anonymity means the ability of being unknown. So anonymity, these comes into the picture when we are collecting data. But still, there are various sources which are open source, and then we can go there and collect the data. All right. So this is all about the data collection. Now moving on, the third step, that is data cleaning. So data cleaning means so again, data cleaning is a very what you can say is a very small term when it comes to this step. According to me, let me see the next slide first. Right. So data cleaning is a very small word, because data cleaning is just one part of the step, which I term as ETL. Right. Extract, transform, and loading. So again, data cleaning is just one part of it, right? Before that, you have to extract the data. So now you went online, you saw this data, but the first and the foremost step is to extract that data from that data source into the tool that you will be using for your data analysis. So the most common tool that we use while learning is Power Query Editor, right? So in order for me to extract this data into Power Query Editor, I need to, I need to extract the data from that source. So again, not just Power Query Editor, we also have pandas in Python that's helpful for ETL. We also have SQL, which is also helpful for ETL processing. But data Power Query Editor is one of the most easiest and user-friendly tools when it comes to ETL process, right? So there are several steps that we follow. First, we extract the data. We extract the data. Once we have extracted the data, then we move on to the data transformation. And the data cleaning, what's written on the screen, is just one part of data transformation. So in data transformation, there are several processes. There's data wrangling, data cleaning, data formatting, and so on, right? So what steps do data transformation include? First is missing values, handling the missing values. So if you might have seen some data before this, you might have seen that few of the data sets, they all of the cells, they do not have their values filled up, right? Some cells are blank, some cells have some abrupt values in it, right? Whenever such kind of data we extract this kind of data into our environment, usually they end up being a null value, you know so the first and the foremost step is to handle these null values, right? It's possible you might see a null value or a nan value, right? Nan means not a number. So you might see such missing values in your data set. The first and the foremost step is to handle these values. Now, how do we handle these values? Either we can drop these the rows that contains these values, or we can replace these missing values with some other value. So what other value can we replace it with? We can replace it with a statistical inference, maybe mean, median, or mode of the remaining data set. Or we can, interpolate and find out the missing value, or we can extrapolate and find out the missing value. We can also replace it with some default value, right? We can also replace it with a default value, which we might know of. We can also replace it with a zero. If it has nothing, it's possible it contained a zero, and that's why so no one wrote anything in it, and it ended up being a null value, and that's fine. We can replace it with a zero. Or we can also use some machine learning models that predict what null value would have been there. Now we have several machine learning models that can predict the null values these days. But again, I'm moving more into the domain of data science, but we are talking about data analysis over. So keep the machine learning part aside. The other steps is how we can handle the missing value. Then comes removing errors or duplicates. So data has null values, it has duplicate values, it has errors. So again, we handle them the same way. We either drop them or replace them with some other line. We standardize the formats. For example, data. Sometimes data is not in the correct format that it should be. Sometimes a date format data is in a text format. So we need to make it correct, convert into the correct format in the date format or a currency format. Right? And we should also eliminate the irrelevant or noisy data. One such type of noisy or irrelevant data is called as outliers. So if there are outliers in our data, we need to remove them, we need to eliminate them. So this is the transformation part of the ETL process. Now, once we have transformed our data into the desired format, next step is to load that data. Load that data somewhere where we will be using it. So usually this step is called as warehousing, right? We store this into a warehouse. Once you have, it's just like how we work with some mechanical parts. We extract these parts from a vendor. We perform our processes such as lathe machine, this and that, and then we take those to the warehouse for storage, from where we can use them for assembly or maybe to sell it to another, customer. So again, so this is how it works. Extracting the data, transformation of the data, and then loading that data somewhere, maybe in a database, in a data storage facility. All right. So this is the step three, that is data cleaning. All right. The next step is data exploration. Now, Just like I told you, this stage is better known as exploratory data analysis. So, what this exploratory data analysis is, we use this to get an idea about the data. Get an idea about the data. Now, first bullet point says use basic descriptive statistics. Again, so descriptive statistics is descript. These are not the complete descriptive statistics. We have mean, median, mode, range. We have minimum. We have maximum. Right. We have count. We have distinct count. Right. We have several other descriptive statistics. We also have this variance. We have standard deviation. Right. So why are these called as descriptive statistics? Is because these values helps us describe our data or summarize our data into just one numerical value. For example, if I have 100 students in my class, right? And I need to report how the batch is performing, right? Now, when I say batch is one entity, right? But that one entity consists of 100 students. But when I say it as a batch, it is collectively called as, uh, 100 students are collectively called as a batch, and that is just one entity. So if someone is asking me how the batch is performing, I won't be telling them the scores of all the 100 students, right? I need to provide a summary of these values in one numerical value because batch is one entity. All right. So all these values that you can see on the screen that will help me summarize my data into just one single value is called as the aggregations which help me describe the data, and hence this type of statistics is called as descriptive statistics. All right. So we all know mean, median, and mode. We have learned it in the 8th standard. Whenever we have some data, we sum it all is sum all the values and we divide by total count of values, which will give us mean. Median we calculate by arranging them into an ascending order, and then not count, but in order, whichever would lie in exactly at the middle would be our median. Then mode means the value that has, what I can say, the mode is the most frequent value. So the value that has occurred in our data set the maximum number of times is called a mode. Then there's standard deviation, variance. There are several descriptive statistics that you can find. If you go online, you can see there are several types of these values. There's minimum, there's maximum count, distinct count, there's sum, there's covariance, there's several others, right? There's coefficient of you know coefficient of variance. There are several descriptive statistics that you can find, but out of which the ones that I mentioned on the screen are the most important ones, right? So this is how we explore the data. Then we also identify patterns, trends, and outliers, right? So we identify these patterns using a few, you can say, maybe the data. We can summarize the data and see the patterns, the trends, right? We see the outliers in box plots and so on. And then we'll also make small, what I can say, small but what I can say, univariate analysis, such as creating histograms, creating pie charts, tables. That will just help us get an idea about the data. We'll see the shape of the data, the number of rows, the number of columns. We will also see what each column means. For example, if one of the column in my data set means BP, right? It says BP. Now I know this is a healthcare data set. So by default, BP should mean blood pressure, right? This will confirm when in the data points I'll see 180 slash, I'm sorry, 120, I mean, sorry, 120 slash 80 and 130 slash 85. If I see such values, I'll say this is definitely blood pressure data. So what we do is we try to understand the data, right? We try to understand what this data means. Okay. So this is all about data exploration or exploratory data analysis. Now comes the most, what I can say, sought after type of data analysis, which is the core data analysis, in which most of the people, well, almost everyone works on the core data analysis, and everyone else, everyone tends to forget the every other step. So from 1 to 8 steps, everyone is focused on this fifth step alone. Now, what is this data analysis? So it involves applying comparisons, correlations, and groupings. We perform group bias. We perform creating pivot tables. We try to create visualizations. We try to write queries. We join tables. We see the correlations between them and so on. Use logics and statistics to find relationship between two graphs or two variables. Right. And then we ask questions like, does the x impact y? So if x and y both are numerical continuous variables, so if I increase the variable x, will y increase or decrease or will not change anything at all? This is calculated, or this is found out using correlations. So this will tell me if X impacts Y, right? And then the next question we can see is what happens over time. So this comes under the time series analysis, wherein we see what happens over time, or like how a variable changes over time. All right. So this is the core analysis. I guess this every one of you might be pretty sure, or pretty much uh, yeah, what you can say, explored to this or exposed to this step in the data analysis process, which is the core data analysis, right? So I'm assuming you might be knowing how to create a dashboard and how to, create these visualizations and all. And even though you don't know, I cannot explain you, because this lecture or this YouTube live is not about that. We can explore that, or we have explored that in previous YouTube lives. You can go and watch the other videos where we have created this dashboards and other stuff. But this is more focused on the data analysis processes. So let's move on to the next step, which is now the most ignored step, you can say, or not the most ignored, but the starting of the ignorance. So from here, the ignorance starts. From here, the overlooking starts. Now we have created a dashboard. Everyone thinks that we are done with the project. They just keep, they might put up a LinkedIn post showcasing their, dashboard, or maybe put that project on a GitHub. They'll create a repo on GitHub and they'll put that on GitHub. Maybe they'll share that project to their professors or to their peers, right? But a very key process after this is interpreting the data. Once you have created this dashboard, it's very important to find out the insights from this data. So the first bullet point, it says translates stats into actionable insights. So whatever graphs we have created, now it is our time to translate these graphs into actionable insights. This is one of the very key, what you can say, skills that a data analyst should have, is to generating the insights or interpreting the graphs. All right. So, for example, if you have a graph and you see that the sales is constantly increasing in that graph, whereas you see the profit is not increasing or it's stable. So, one insight from this graph we can generate is that even though the sales is increasing, the profit is not. That means the net profit that this person or this business owner um, is constant, whereas the sales are increasing. So it's possible that the company's expenditure has also increased along with the sales. So it's possible because most of the times what happens is you need, in order for you to increase your business, you need to put in some money, and with that money the sale increases. So it's possible that with the increasing in sales, uh, or whatever money this business owner has put up in his business has gone into growing the business. All right, it's possible, it happens. And this is the reason why the net profit remains constant. So it's okay if my net profit remains constant, because eventually it might increase once I have, increased my customer base using this marketing campaigns. My business will increase. But once, um, it's okay if net profit is constant, but the problem starts when the net profit starts decreasing, and that's when you have to be vigilant about, and you have to let your stakeholder know about it. So this is what a way of converting or translating your stats into an actionable insight, right? So this is how you need to do. All right, then link back to the original question and problem. This is very important. This is very important because this will keep you in check whether you are on the path of solving the problem or not. Or else, what will happen is I'll be talking about, what I can say. I'll be talking about hiring, how hiring has changed, whereas my original objective was to find out sales, right? Or I will end up in talking about why people are leaving the company instead of talking about why the sales are not increasing, right? So, in this interpretation stage, we also need to link these insights back to the original question. It is very important to do that. All right. And then also acknowledge assumptions or limitation. So, this is because whenever we interpret our data, we also see that we interpret using some assumptions. For example, so if I'm saying, for example, I have a sales data, and this sales data is categorized into various categories based on regions. So there are four regions: north, south, east, west. Now I see that in the northern part of the geography, the sales are increasing, but in the east side it is not, whereas in the west and the south they are constant. So one interpretation that I can make is that the customers that were with us in the eastern region have shifted to the northern part, and that's why the northern geography's sales is increasing. But again, this is an assumption. Is this true? I don't know. All right, I don't know if this is true. This is just one of my assumption, or because interpretations are based on assumptions. Most of them are based on assumption. So that's why if I need to tell my interpretations, I have to also acknowledge the assumptions that I have made. All right, so this is what this tells. This is what this interpretation is. Okay? I need to acknowledge what the assumptions I have made along with the interpretations that I have given. All right, now let's talk about the new stage or the next stage, that is communication. Now you might have see now communication, right? Let's talk something about communication. So, what do you understand by communication? One might say, sir, this guy, he's very fluent in English. He's very, very good at English. And that's why he's very good in communication. Right? It's possible. Now usually people see the people who are good at speaking English, they generally tend to consider them as good at communication, but this is not the case. This is not the case. Speaking good English does not mean that the person's communication is good too, because communication means the ability to explain the thoughts that I have in my head into someone else's mind, to make someone explain what I have in my mind And if the person in front of me understands that, that is known as communication, right? Language is just a tool for communication. You see, because it's possible now, if you say, if, for example, my English is good, like my spoken English is good, and I go in front of my stakeholder. Now, my stakeholder, he earns crores and crores of money, right? He earns crores and crores of money. He's very, very fluent in his own mother language, maybe Marathi, or he's very good at Hindi. He does not know English. And if I go in front of him and I explain the dashboard to him in my very fluent English, will I be a good communicator? Of course not, because the person in front of me would not be able to understand what I'm saying. So that's what I mean to say, the difference between the language and the communication. So it's okay once in a while if you are not fluent in English, it's okay. अगर आप थोड़ी सी हिंदी बोल लेते हो बीच में तो कोई बुरी बात नहीं है, अच्छी बात है. But you need to communicate. So once it's okay to use some Hindi words, बीच बीच में थोड़ा हिंदी बोल लिया चलता है. It's not that bad. But अगर तुम बीच में कम्युनिकेट करते समय ऐसे अटक गए, ऐसे बोल रहे हो, so that is a blotch on your communication. So थोड़ा सा याद नहीं आता है इंग्लिश के वर्ड्स, हिंदी बोल लिया चलेगा, लेकिन your communication should be perfect. So पहला जो है, first point is use visuals, bullet points and simple language. So language should be simple. Again, बहुत बहुत बार क्या होता है, people or students or data analysts, they use jargons क्या होता है, ऐसे भारी भारी वर्ड्स यूज करते हैं इंग्लिश के, लाइक शशि थरूर, लाइक ऐसा लगता है कि शशि थरूर बात कर रहे हैं, ऐसी इंग्लिश यूज करते हैं, सामने वाले को नहीं समझता है. सो देयर इज नो पॉइंट इन स्पीकिंग द टफ English or the ornamented English or the Shakespearean English. It's not necessary. You just need to speak basic English, but you should be clear. Be clear in what you are speaking, right? You should use bullet points because bullet point conveys your message very strongly in a very short manner. All right, and the best part in communication is visualization, because I've never seen a person who has liked reading a text on your screen more than watching a visual on your screen. So visual keeps audience interested, and that's why we create dashboards, we create visualizations, because that keeps the person in front of me interested. All right, that's why communication matters. Then second is customize for audience. Again, just like I told you, if my audience is technical, I need to speak technical words in front of them in order for them to understand what I'm speaking. And if it's managerial, I should avoid technical jargons because they will not understand the technical jargons. Assume you are sitting in front of a stakeholder who has never ever touched mathematics, and then you go and uh, keep on talking about Bayes theorem. You go and keep talking about knife Bayes optimization or machine learning algorithm, or you talk about gradient descent optimization technique. He'll just get bored, and it's possible you will not get the project. Someone else will get the project. So always, it's there's a word in English called as sense the room. Sense the room. Sense the people sitting in front of you. Sense how will they, what language will they understand in, and always try to communicate them in their language, not your language. All right. And then incorporate storytelling. So storytelling is a very, very good skill, not just in data analysis, but anywhere. If you are a good storyteller, you can get anything in this, you can get anything in this world. You can sell anything. You can do anything, can make anything. You can ask anyone to do anything if you're a good storyteller. You can keep anyone interested. You can hold a conversation. You can be a very good data analyst. You can be a very good data scientist if you are a good storyteller. So always and always be a good storyteller, because that keeps everyone interested in your talks. All right. So communication is one of the very important aspects when it comes to data analysis procedure. Now let's talk about the last step, which is decision making. So now we have done this data analysis process, everything. We have created dashboards, done everything. We have brought our insights. We also communicated them to the stakeholders. Now, once we have communicated the what you can say the interpretations, now is the action stage. Now now the person has to take the action, and that actions we have to suggest them, right? We have to suggest these decisions or these suggestions or prescriptions to the stakeholders in order for them to take the action on it. So for example, our problem was why the sales are dropping. This question was our problem, that why the sales are dropping in my store. Now we went through the data, we did our data analysis, we found out why it is happening. Now we have to prescribe how can they improve their business, how can they improve their sales. So we saw that it's possible that the northern region was performing very good, but the east region was performing so bad that the aggregate sales were dropping down, and that's where we have to provide them with the solutions for their problem. So either we can say that since the north side is increasing, we can invest a small amount of money in the northern region in order for them to improve their sales or increase their growth furthermore, so that the total aggregation might go positive and the sales might improve. And the second insight or second prescription that we can give to this business owner is that they can they can focus on the east region to find out why their sales are dropping in this region. So maybe it might be happening because of the maybe the people over there are not aware about the brand, or maybe there might be some kind of political tension going on, some or the other reason going on. So we need to focus on that region and prescribe them to solve that region, solve that problem which is revolving around that reason. So that's the first point, that is telling that suggest specific data backed action. So what we saw in our data, now we are suggesting them the actions backed by the data. All right. Then recommended further study if needed. So it's possible that you are not able to solve the problem with all the data that they have provided. So it's possible that you might have to further study their data. So what you can is recommend them that a further study is needed. So you can ask them that so and so data you need to gather so and so data, and if they are willing, you can implement the data gathering process yourself in their store using some method, using some sensors or anything, right? Again, you can gather that data and then you can recommend that the further study is required, and then highlight impact on business goals. So your focus should be solely and wholly on improving the business, because business improving the business means improving the money, improving the capital, and money runs the world. That's the main motto. Money runs the world, and if you're increasing someone's money, if you're increasing someone's sales, if you're increasing someone's profit, that means in turn you will also be improving your own profitability, your own sales, and your own money and net worth. All right. So this sums up all the 8 stages of data analysis process. All right. So to summarize, first is data analysis turns questions into decisions. Right. Data analysis can turn these questions into decisions. We saw the whole process is all about, it starts with a question and ends with a decision. Right. Clear steps ensure clarity and impact. So if we follow these steps, there will be what you can say a very clear very pure clarity in your mind about the steps that you have to take, about the direction that you have to move. So your efforts would not be wasted in, deviating into various other, what I can say, aspects of data analysis, right? And practice, ethics, and communication are key. Just like I told you, practice makes a man, not just a man, also a woman, perfect, right? Ethics is important because you are handling someone's crucial data, someone's private data, someone's very sensitive data, right? So you should be ethical in handling the data. You should not use that data for some unethical purposes. You should not sell that data, right? And third is communication, because without communication, what is a data analyst, right? Without communication, nothing is possible, right? Knowledge transfers happen because of communication. Science progress because of communication. It's that important. You know, give it a thought sometime. You will understand what I'm saying and why I'm saying that communication is very important. All right. This was the summary. And again, we have reached to the end of our slide. And I would like to thank you all for being very patient and listening to this hour-long video. I think, yeah, an hour-long video, almost an hour-long video. Uh, Thank you all for attending this YouTube live, and I hope you would attend more such YouTube live in future, because this was on the basics of data analysis. Now we'll be talking more about the in depth data analysis. We'll be talking about various data science aspects. There's machine learning, there's AI, there's various other stuff that we'll be talking about. So again, thank you all, and if you have any questions, you can always drop in the comments. I won't be able to answer them now because we are almost out of time. But again, if you have any questions, you can drop them in the comments and we'll try to reach out to you and solve your questions. Not with data analysis though, but yeah, we will. So again, thank you everyone, and meet you in the next YouTube live. And until then, see ya and you have a good day. All right.